hopefully Laura will be here shortly. So, oh, there's Laura. Speak of the devil. You're muted.
Hello.
Hello. I figure I let you do all the teachy stuff.
Yeah, we'll see. I feel like I guess I'm not entirely sure. I was figuring to kind of give an overview of what I kind of mailed out yesterday, just so they have a bit of an overview, and then
Yeah.
I'm kind of hoping they can go through the tutorial a bit in their own time during the week potentially.
Yeah, and I was looking through the code from last year too to try and refresh my memory as to what some of the issues were how we did things, and some good examples of stuff that's already implemented.
Yeah.
Like the big thing is going to be commands. And like we had the Blinken controller all set up and ready to go, which was the flashy LEDs.
Sonar. Okay.
And we had the sonar working too. So I had that coupled to the sonar. So, and there was another also had it linked to the color detector as well. So the color sensor. So that's there. That's a good example of a command that works. So I'll experiment this week and get a basic project up there. So versus just re-importing last year's project.
Yeah.
No, there's Ethan. I didn't hear anything back from Bella, so I don't know if Bella will be able to make it or not. So, and there's Bella. Speak of the devil.
Awesome.
I hadn't heard from you, so I didn't know if you were going to make it or not. So
sorry, I got home late last night. I had to leave after the robotics meeting.
Oh, no problem. Turn that off. So, yeah. Okay, so I'll let Laura get started, and I will jump in as needed or whatnot.
Yeah. So I figure first we can just do like a round of introductions because we don't really know each other that well. So I guess I'll go first, and then we can just go around however. But hi everyone, I'm Laura. I only just joined as a mentor last year, so the robotics, first robotics is still somewhat new to me, but you know, did you know, have practice and whatever with the dev board and deploying stuff. So I'm definitely still excited for this year and learning more. And aside from here, yes, I like work at Nordstrom, have been there for a few years, and I'm now on the like payments platform there.
2 years now, right?
Yep, 2 years. Yeah, just over 2 years. And other than that, you know, I love plants, do yoga, like reading, like hiking, stuff like that.
So, so I'm Wade, even though it says I'm Elisa in the Zoom. That's my wife. She paid for the Zoom account, so her name's on it. I've been doing FIRST Robotics for longer than Larry, probably about a year or two longer than Larry, probably about 17 years now. I used to work at Nordstrom. I used to be Laura's manager. That's how Laura got sucked in, is she's like, I kind of want to do something like this, so I sucked her in. I currently am not working. I'm currently searching for a job, but my past career experience, I spent a lot of time at Microsoft on a small product called Windows. I worked on basically every version of Windows from Win 2000 to Win 7. I've done various other different things. I was at Nordstrom for 5 years. Basically last in the analytics platform, which I hired Laura. She worked there due to the pandemic. Things have changed. She is now in the payments team. She actually was kind of helping them out when I left. So yeah, so I have always had fun with FIRST. I enjoy it. I like the students I enjoy it even more when the students do the work. Some of the past mentors past students that really got into programming have gone on to work at like Nintendo and Microsoft and stuff. So not that this is a career path, but or it is a good way to get started, and you may realize, hey, this is actually kind of fun. And it's not as hard as people think it is. And we're here to help you guys out. So next, how about Olivia and Kayla, I guess. Since they look so excited.
I'm Olivia. I'm a sophomore. This is my first year doing robotics. I love to dance and read. Yeah.
Hi, I'm Kayla. I'm a freshman, and this is also my first year doing robotics. And I like to read, and I like to basically do anything that involves art or music.
Cool. Ethan?
I'm Ethan. I'm also freshman. This is my first year doing robotics. I do a lot of stuff with friends involving aviation.
Cool. By the way, I'm a private pilot. I forgot to mention that. So I have my private pilot certificates. Okay. Bella, I know you've been around for a couple years. So
Yeah, hi, I'm Bella. I'm a junior, and this is my third year doing robotics.
yeah, she's primarily done electronics. So it's great to see you kind of like get interested in something else. Not that there's electronics easier, there's just not as much. So it's great to have multiple eyes on the project. So I will kind of let Laura do the teaching part because she's really good at it. And I will kind of like add color commentary here and there, I guess. So and explain things that she can't necessarily explain. So
Yeah, so not entirely sure how this will all go, but I figured today we can kind of just go over like a bit of the basics of how like the code repositories are. Sent a long email with you guys with just a few links, and so in there was the CS Awesome course that I think was mentioned yesterday, and so that's just kind of a basic you know, a good starting point for learning Java and understanding how Java works, and then also like as a good introduction to coding as well. It gives some good like background and explanation on how things work. So if you guys do have time to kind of go through that during the week, it would probably be awesome to give, you know, some foundation, some better foundation for kind of what we'll be diving into on the weekends. But as you go through it, feel free to reach out with any questions, or you can always pair up with each other and you know, ask questions. I think we're all resources for each other here. So that's the CS Awesome course, and then oh yeah, I guess that too, you can get through as much of it as you want, but I think the main like one, if you get through all the 1 point things, I guess I don't want to, I'm not sure how like timelines can go. You can see how kind of just maybe we'll check in on how long they take to go through and whatever, because I think some of the sections are did say like half an hour or 45 minutes for some of them to get through.
yeah, and I looked through it, and well, I've been doing coding for years. It makes a lot of sense to me. So I myself would go, yeah, it's easy. So I realize it may take you guys a little bit longer. So, but again, just ask questions if you guys go, I don't understand this. So
Definitely, yeah, and take your time to like let things process as you're going through, because it is a whole new world. But yeah, and then with our Seabot robotics, I actually haven't, or I guess this year's code isn't, there isn't really code to it yet. I think
Yeah.
Wade said he would build like some
Yeah.
kind of structure for that.
Yeah, so I invited everybody to GitLab, which everybody's accepted the invitation except for Bella, probably because Bella got home late last night. So I noticed most everybody created an account, and you can look at. I invited you to the group, and you can see the past projects, the 2020 projects. There's actually two 2020 projects. One is doesn't really have anything in it. The other actually has stuff in it. So which is the link that Laura sent out. So if you want, you can browse. The 2021 project doesn't have anything in it, but I'll be populating that this week. So.
And then with these, I guess I didn't give the links to download a code editor, but there's IntelliJ or VS Code. There's a few different ones that we can provide like links on how to download that we would be using to contribute to the code. And then with there's like a command line as well that you can kind of type in different commands, and then that will save your progress. And I guess with Git is a whole is a system for version control, or basically what that is saving progress or like different points of code. So using Git, you can save a certain chunk of code that you've written, and then it uses something called branches that are basically different. I don't know.
So I can share my screen right now.
Oh, sure. Oh yeah, I guess that would be helpful to go as we're going through.
Let's see here. Desktop 2.
But I guess like a branch, you can think of it as like a tree has branches that can be, or I guess that doesn't really, but it can kind of be like a personal project space where you could have your own separate branch, and then you could add different code to it and save your progress there. And then at whatever point, we can then combine the code from one branch with another branch. And then like if one person is working on, oh yeah, right now we see your calendar.
Oh, you see my calendar. Oops.
Yep.
Wrong thing. I thought I was told to share a screen too. Ignore my inept Zoom skills. How's that? Do you
Perfect.
still see
Yeah.
Okay.
No, robotics. Yeah.
So like Laura was talking about, so this is the Seabot robotics group, which I invited you all to. So you see a couple different projects in here. There's the 2019 robot. You can look at that. I will tell you that it may or may not make sense to you, because if you know Java, it may make sense to you because it's actually written in a different language. It's written in C++, which is an older language. Last year was the first year we decided to do Java. Last year's project is this 2020 Infinite Recharge, not this one down here, but this one up here. And you'll see here's the project. And as Laura was talking about, you can see we have branches here. We have a branch for a climber. We have a development branch. We have a feature branch for climber and the limelight camera and stuff. So I can actually go look at this development branch, and I can see what the changes have been made. This is where source control is kind of nice, because you can see I merged a branch from a test branch to master. And if I click on this, you can see what the change was, and you can see, oh, this was a really, really big change here. I changed one line. Probably a little better example. Let's see here. I want to go back. See here. If I look at the master branch, and I go into main robot and pick robot Java. So this is, don't get overwhelmed. I know this is a lot to see here, but this is the main robot Java file, and you can see all the changes that have been made to that file. The nice thing with Git and any sort of source control system is you can look at changes before they're added to a branch, or if something breaks, you kind of know what changed, so you can revert back to what it was when it was working. So here's a change, another merge that we made for the drivetrain, and you can see all the various different changes. You can see what was deleted. This was adding stuff for like the hooking up the sonar to the flashing LEDs and stuff like that. And good coding practices, try to make your code as readable as possible. Like you'll learn about constants. Like I didn't put some, because this sonar green distance could be just a it's probably just a number, but if you just saw the number there and somebody's reading it, they're not necessarily going to go, oh, what's 10 or 25 or what's what is the value for green? Because if when you get into the thing that actually controls the blinky lights, there's actually a whole set of constants that define what the various different colors are. And, yeah, just putting in the numbers is helpful. But this is source control, and you can see branches. You can see a graph of all the various different changes. This is done automatically, so you can see how things merge and stuff, and what's current, and fun stuff like that. Anything else you want me to show them, Laura?
Well, in here, what I'm wondering is maybe if we go to like files or just the main repository, and then from
master
here,
branch?
yeah, this is fine, but I'm just thinking using the web IDE. So if you click on like the web IDE button on the top, it can just be helpful to see a little bit of what the folder structure looks like in an editor, because then it pops up on the left there. And so I think we will, you can look more into this once you have an ID downloaded and to be used, but basically it'll show up in this section to the left. So when you're first looking at the repository, it kind of just looks like a number of links, but really those are kind of files that are at the root or like the base of the project. And then as you would click through the links, it would be like entering these different folders, which is where the end Java codes ends up being stored. So if you look at where like robot Java is, and then you look at that structure of what it's in, it's actually in the folder structure of that like source main Java FRC robot, and then the robot Java class there.
Yeah.
And
so, oh, and here's like all those constants I was telling you about for the blinky LED lights. So
yeah.
knowing that gold is 0.67 is not really, if you saw 0.67 in the code, it's not really helpful. But so IDE, for those that don't know, is integrated development environment. It's basically a program, or it can be a web page like this, that web editor like this, that you basically write your code in. It actually helps you write the code. It'll do autocomplete and other fun things like that.
Yep. And then I think like Wade also had mentioned earlier, it's helpful to, or like just for best practices, kind of grouping things together. So in this project here, we had some of the main like code outside of it, but then within that commands folder, and then there's subsystems folder would kind of be, oh, is there nothing in the commands? Oh yeah, there is, okay. Is just kind of how you'll group different pieces of code that have similar functionality, and then with the constants, grouping all of those in one file just kind of helps with organization to know that that's where the constants would be as well.
And actually Java sort of forces you to do some stuff like this, to separate things out, because don't worry about commands and subsystems right now. That's a FRC specific thing that we'll probably start talking about next weekend. But like here in robot Java, there's this thing called a class, which represents the object for the robot. Think of the object as the robot, and then the robot consists of various different little pieces, like it has a sonar module. So there's a class that represents the sonar module and stuff like that. Java does not allow you to define two classes in the same file. Because there's actually also, you'll notice here, there's an object here called robot, a class called robot constants. All this thing is constants. But I can't define robot constants in the same file as, I can't define this class in the same file as robot. Java will actually complain and force you to separate it out.
Cool. And then, yeah, with this code, I guess I also am kind of curious what people's availability is and how we would test some of these things with the dev station. And then I think that Jeff had also said he wanted to like go through some of the just the basic drive functionality with the actual robot. But I think that potentially there's not access on the weekends there. It would just be Monday to Friday.
Yeah.
So I'm
So the
curious if
dev
we want to make
board,
a time. Yeah.
the dev board, I'm kind of curious how we can work that out. The robot itself, we've come up with, if we did the Zoom thing, I basically need to build a 100-foot Ethernet cable so that we can tether if we need debug and stuff, but we can basically run Zoom on the driver's station and share a screen that way. And Bella's going to be driving, so Bella's probably going to be the one driving it. So if there's something people want to test out on the dev board, they can check it into Git. They'll teach you how to get things into Git into like a branch or something, and then whoever has the dev board can download it, and maybe we can do virtual test session that way.
And I wonder, you have the dev board right now. Would you want to just like
Yes.
hold it up so people can see what it looks like a little bit?
Sure.
Because it's pretty cool. But if you haven't seen it before, you might not know what we're talking about.
Bella's seen it. Let's see here. Trying to pick it up so it doesn't like rip wires out. So this has all the components basically. This doesn't have the exact same components as on the robot because we're actually using some different speed controllers for the newer motors this year or last year. That's the same, but we can actually, and that actually last year we made the code so it was easy to switch between. But basically, it has the same. It has the robo reel right here buried underneath all the wires. The same basic Wi-Fi controller. There's a camera here. These are speed controllers, and there's a couple little motors here to represent the drive motors, the limelight camera, and there's some switches up here that we have for simulating switches on the robot. So like limit switches and whatnot. So.
Yeah. So it basically has like similar, same components that would be on the actual robot. So then once we have code, we can hook our code up to this dev board and then see what, runs as we're expecting it. Like when we're testing the motor would
Yeah.
spin, and you can see the response that we're expecting just from that.
It's helpful for like autonomous modes and stuff like that, like testing, like, or mechanisms where you're having a command run and like I want to go X number of distance and then turn and have it test the logic and stuff like that without actually having to use the robot. The going a distance and turning part is a little more difficult to do on a dev board, and we actually have an encoder on a gearbox there that we can actually turn it, and the encoder will move. But if you're doing things like in past years, we've had to do ball loaders, like I need to run this motor until this limit switch gets triggered, or when I push this button, this motor needs to run until X thing happens. That's really good for testing that stuff out.
So I want to take a quick break and just see what questions people have so far, because I feel like there must be some.
There, Bella's still smiling. Olivia and Kayla are kind of like, they're grinning. Ethan, guys, don't be afraid.
I understand some of it. Other parts, I'm like, I really need to get to the book that you guys put on the for the
Yes.
lesson.
Yeah. So when they start talking about objects in there, so I'm going to go to another project that I've been working on, and it's a little bit complicated when you first look at it, and I can give you guys access. I think the project is public. I can send it to you. So there's a project I've been working on. So everything in Java is basically objects. And I will admit that was the hardest thing I ever had to learn when I learned learned programming was objects. What are objects? It's just not right. So even an application is an object. So when they start talking about objects, you're going to hear a lot of classes. Also classes, it's the definition of the object. So everything is an object, even the application here. Think of the object as like the robot or the arm or the blinking lights on the robot. Here, I have a simple application. Objects will have attributes like things that they may consist of other objects. They may consist of things that describe the object, like, or indicate what the object state is. Like, if you have a robot and an arm, or you have a drivetrain. In a robot, you have a drivetrain, right? And you need to be able to tell it to go forward, or you need to tell it to go backwards, or you need to tell it to turn, or you want to know what the state of something is. What are the blinking lights currently doing? So telling it to do things, those are what is called methods or member methods. And like for an application, every application has this thing called main, which is the main entry point into a program. When you have a car can be represented as an object, because a car has other objects like brakes and engines and stuff like that. And then you have different types of engines, because then your car may have a electric motor, or it may have a gas motor. And it can get a little more in depth and a little more fine-grained detail than that. So there's a way to inherit from other things and stuff like that. And it's covered in the course, but just try to think of the objects. So let's see. So like when I tell the robot to go forward, all it's doing is it's calling a method to say go forward, or turn right, or turn on the blinking lights. And then if I want to know what the blinking lights are doing, then I can look at, so this would be, I think the blinking lights is a good example. So not that, source, main, Java, RC, robot. So here we have the blinking, which is the blinking thing. It has a bunch of constants, and we have a bunch of variables here. There's something that tells me what the current color is. There's something that tells me what the primary color is, or the alternate color if I want to flash between two different colors. It's something that tells me what the interval is between the flashes, and then this count was an internal thing. It's an internal count to be able to figure out, do I need to switch colors or not? And is it blinking or is it just on? And all these other things. So are things on how do I create an instance of this blinky thing? And how do I change the primary color? How do I set the other color? How do I change the interval? How do I tell it to blink? And some other things down here on actually controlling the blinking. So this actually has to do with commands, which we'll get into later. Does that make sense?
Like I got the first part, and then yeah, no, I think that was good.
But just try to, when you don't try to overthink it a whole lot. Just like, and since I was a manager for so long, I always asked this sort of silly, stupid, simple question, because I was like, I'm a manager. I don't know all the technical details. And Laura will probably attest to this. A couple times, people would explain stuff to me in extreme detail, and I go, what? Let's dumb it down here a little bit. I'm a manager. I haven't done technical stuff in a few years, so you need to kind of like make it a little simpler for me. And then I was able to get it. It's like, but just break it down. And it's like, well, we have this ball collector. Great, that's an object. Okay, what does the ball collector consist of? Well, it has a motor. Okay, that's another object. And for the robot, there's actually a whole collection. There's a whole library of stuff, which is what's the WPI lib. It's a whole collection of objects that you can use to write code. So you don't go, well, how do I need to run this motor. Okay, well, there's a motor object. And if you add a motor object to your ball collector, when you want to do ball collector run, you can run the motor. Or there's little things to say, oh, I want to tell this motor to run at this speed. It's not like you have to get into low level, like, oh, I need to go change a spark controller. It's not that complicated.
Yeah. And so that WPI library is something that was, I think, created by First Robotics, kind of like
Yes.
specifically for this, for use from all these teams. So they have those kind of base objects or classes for
Yeah.
most of or all the components that you can buy and use through First Robotics.
So up here at the top, you see all these import statements. These are importing various different other libraries or classes. And you see, hey, there's all these WPI lib stuff. These are all WPI lib. Those are all libraries. So,
yeah. And then I guess just high level, once all of the classes are kind of created, then that's when you can program, if we have I don't know, a ball collector or something that then uses multiple different actions to make up what we want to do, then we can have it, there's different, like a joystick or remote, there's ways to trigger the actions for the robot. And so you can make it that if you were to press a button on the joystick, it would then follow a certain set of actions to perform what you want it to do.
yeah.
And so I wonder, I feel like, oh yeah, we can go into that project a bit. But then
Yeah.
afterwards, I feel like we should kind of just talk through like what we're going to want the robot to do this year too. But yeah, you can show this project.
Yeah. So what I was going to, where the main application is not a good example of objects. So in here, I created a bunch of different things. So this application goes out and gets data on airplanes that are flying around. It does flight tracking basically. And so I created this hierarchy of What I should do is basically I have this base, everything is a request. So I created a base request class, and then there are there's an airport flight request, which this guy, so flight requests. So flight requests, it inherits from this base request. The reason you do stuff like this is so that you're not writing the same thing over and over and over. And it makes it easier to kind of like fix things later. So flight track requests, so aircraft flight requests inherits from here. And when I create, there's these things called constructors, which you'll learn about in the CS Awesome course. This is if I want to create a flight request, I need to create an instance of this thing, build a car or a robot, or what are the things I need to do that. And then there's a method down here, update parameters. I wanted to show like this sort of like hierarchy of Doxygen does a really good job of it. I haven't run Doxygen against this, but it shows this nice little hierarchy of how things inherit and stuff like that. So. And then there's objects down here that show a flight. What's all involved in a flight? What are the, this is just, this guy does, it just holds data. The same with the state and stuff like that. So, and then there's a utilities class down here that does some like utility stuff that I wanted to do. Because in Java, everything needs to be in a class. So if you have a bunch of things, utility functions, you can put them into like a class that's like utilities. Like I have a utility for parsing for parameters and building parameter strings and some time utilities for converting times and stuff like that. This you won't have to worry about as far as like, don't worry about the actual conversion of times and stuff like that. That's just specific to this project. So I'm sure I've totally confused everybody now. You can tell me to stop talking anytime.
Yeah, so I think
Kayla looks totally lost. But I think the best thing to do is to start with Unit 1 of CS Awesome, read through it, because they're basically going to show you hello world, how to write a simple Java program that will do basically output the text hello world. And that's usually the first thing we do when we're learning a new language or doing something new is start simple. Start with, how do I output the numbers from 1 to 10? So, without doing print 1, print 2, print, you could do that, but there's easier ways to do it, which teaches you a little bit more. But because I remember that from college, one of my professors told me, it's like, if you want to learn a new language, the best thing to do at first, other than hello world, is to write a small little program to output the numbers from 1 to 10. It teaches you how to do loops. It teaches you how to do condition checking. It teaches you how to output stuff. So.
nice. So I guess from here, again, any questions you guys have, we're definitely happy to answer. And then otherwise we can either go over kind of what we want the robot to do this year and talk about that, or if you guys want to just have time to get started on the CS Awesome, and then potentially in, I don't know, an hour or two, you guys could email us with just how it's going or any questions, or what do you guys think you'd like to do?
Because I will tell you, sort of like what I told Laura when she started at Nordstrom, because we'd always meet like once a week. I told her it's her career, not mine. So this is your guys' robot, not mine. Without you guys, if you guys just sit back and let us do it. My attitude is, yeah, it's not going to get done. We're not expecting you to do the whole thing. We're here to help you do it. We're here to help you learn it and teach you some things. But just to let us sit back and code the whole thing, yeah, that's not going to make us very happy. And we're not going to do that. Because I have spent many nights in the past in a hotel room coding with the dev board, writing robot code, and then the next morning the student go, oh, I finally wrote it. It's like, oh, you yes, you were supposed to do that a couple of weeks ago, but okay. So it's okay to fail. And this is a line I've been saying in my interviews lately too, is it's okay to fail as long as you know when we fail, we don't take it personally. We just learn from it. We move on. I'm not going to go, oh my God, Kayla and Olivia and Bella, they just are idiots. They don't get it. That's not what I do. And I think Laura can, from her professional experience with me, will tell you that's not what I do. I've given Laura projects in the past, and she's actually come up in some of my interviews, not by name, but because I get asked, like, tell me about a time when how you grow your employees and stuff like that. I've given her projects that she's like, I'm not sure I know how to do this. And the project I bring up is the Flink, replacing the Flink pieces. She didn't know Flink. I didn't know Flink. I still don't know Flink. It's something, but she went and she studied it. She learned it. I was like, I'm not expecting perfection, but and she replaced it with some Java technology, I believe, a Java application, and she takes. Yeah, shut up, Siri. I have my hearing aids in, and somehow Siri got triggered. But it's just having that, yeah, not being afraid to ask for help, because I was like, I'm here to help, and I don't necessarily always have the answers, but together I'm sure we can find the answers. So, and yeah, my other, I guess, philosophy on asking for help is it's okay to ask for help, but also when you ask for help, say, hey, here's what I've done, here's what I've tried, here's what I'm just kind of stuck, versus just going, I'm stuck. Okay, well, what's going on? What have you tried? When you say I'm stuck and here's what I'm having a problem, here's what I've tried, here's what the issue is, it shows that you actually have put some effort into it and you're kind of like invested in it, which if you just say, I'm stuck, fix it for me, you haven't shown much investment, which then I go, okay, why am I doing this? But if you show that you've made an effort, no matter what the effort is, at least if there's some effort, that goes a long ways towards us helping. And then then we don't have to waste time going, well, did you try this? Did you try that? Did you, where, us trying to figure out what exactly you're stuck with. So does that make sense? Seem fair? It's a real world lesson. So yes, Laura and one of the other engineers I used to work with or manage, they come up on my interviews fairly frequently. So cool. So you guys just want to start studying the CS Awesome stuff on your own, or And don't be afraid to speak up. I should make you guys turn the mute off on your.
Is there like a way that after, since I know like I'm just like a couple days going over this, if we could have a
Mhm.
Zoom meeting sometime to go over it?
Mhm.
That way, if like I do get stuck or like
Yeah.
if there are any
So-
comments.
So my availability this week is I am, other than tomorrow morning, I'm pretty available. I only have, so far this week, I think I only have interviews tomorrow morning. So,
Yeah, and me
Yeah.
potentially evenings. But also if you have any questions on that you send over on email, I definitely be able to respond to those as
Yeah.
well.
For me, I'm more available during the day. Currently, Monday evenings, I'm a little less available. I have some. So I have volunteer meetings. I volunteer with Civil Air Patrol, and we have meetings on Monday nights and a little bit on Tuesday night. But other than that, I'm pretty much available anytime currently. Other than this Monday at 9 a.m. to 11 a.m., I'm kind of busy because I'm trying to get a job.
I think Kayla and I are good for any time except for Monday nights. I think we're good.
Pretty much, yes. And I will respond to email fairly quickly sometimes. And I'm sort of a night person, so the fact that I have a 9 a.m. meeting tomorrow or interview tomorrow morning doesn't really make me happy because I've been a slacker lately, and since I haven't been working, I really like to sleep in. But and I will stay up till 3 in the morning, which isn't great. But yeah, just anytime. And if you want to meet with Zoom or whatever, anytime I have access to an account, I can set up a meeting. And it can go as long as it needs to go. So I can. So who has a Mac? Does anybody have a Mac? Other than Laura, she doesn't really count. So everybody's on a Windows PC. Okay, that makes life a little easier. Because in theory, with the Windows PC, you can actually run the driver station, and because with the dev board, you're basically running the driver station that runs actually on the driver station. That's how you control it. If we did get to the point where we wanted to get the dev board to you, there's a way to do that. You could, we'll think about that. But the development environment is a little easier to install on. I don't know if it's easier or not, but you could actually download code and stuff. Who does anybody still have Windows 7? Everybody's Windows 10? Yes, Windows 10.
Checking, but I'm pretty sure, yeah.
Windows 8 is horrible. Windows 7 was the last great version of Windows. Windows 10 is okay. Windows 8 was horrible. I did not work on Windows 8. I did not work on Windows 10, but Windows 10, actually, it's really easy. I'll send out the instructions for installing the development environment for WPILib. Also IntelliJ and VS Code. The first development environment does use VS Code, but when it installs, it downloads its own copy of VS Code and sort of like installs it off on its own. But if you wanted to do your own little Java programming, you could use something like IntelliJ or VS Code, the normal VS Code, and do it outside the burst environment, which is a little more, can be a little bit more fun to explore things that way. Let's see, I was going to see if I could share. I'm going to, share screen. See if I can find IntelliJ. I should have it running. IntelliJ, there we go. So so everybody sees this gnarly looking window, right? So I just want to show you, even I on a new window. So let's see. Does everybody see Flight Tracker or do they see Hello World?
I see flight tracker.
Okay, wrong. I had to do the wrong thing. Let's see. See flight new or recent. Hello World. Do you see anything now, or do you just?
Nothing yet.
Oh, okay. Share. I'm trying to bring up my Hello World thingy.
Okay. And I guess the one other comment I had was don't be afraid to, in the emails, you can just do reply all,
Yes.
and it'll just send us all. And then we can all know
include
where.
Larry to include Larry too, because Larry will be able to.
Yeah.
Okay.
Yeah, I
So
think Larry's on the main.
Yeah.
Was on my first message.
Yeah. So I think this is my Hello World thing, which I started off doing Hello World, but then it sort of like morphed into a whole bunch of other crap that I was starting to test other things. I was like, well, I really want to do this other thing, and
Yeah.
but you'll notice there's a numbers class here. This is something that I was doing just to like learn Java. Like I want to write a way to add two numbers, and so I wrote this simple little thing that takes two numbers and you can add them together and stuff like that, and other fun stuff. Which Hello World, and this sometimes happens is I start with a little Hello World program, and then it just like explodes into a whole bunch of other stuff that it turns into my little test bed for playing around.
Yeah. But I do the same. It's kind of nice to have like a little scratch pad where you can, just put whatever, import whatever, and then just test some small piece of functionality quickly.
Yeah. So this Hello World class actually doesn't. All it does is has one function. It just has main, and it just goes through and does a bunch of stuff. And so it's not really super complicated, but anyhow, cool. So you guys want to get? We'll let you guys get started on the CS Awesome stuff. When did you guys want to meet again? Or did you just want to like say we're ready to meet, or did you just want me to pick like Wednesday or Tuesday? Bella, you're muted. You spoke, but
Yeah, sorry, that sounds good to me.
Okay.
I am available usually from 1 to 2,
Okay.
because from that I then have other classes that I have to continue doing work for, even though it's our gap week.
Okay. What about the rest of you guys? You're Kayla's talking, but I didn't hear anything. Or somebody. I'm learning between Kayla and Olivia. I still don't have it. Somebody was
I think
talking.
Olivia was talking. Is there Olivia's on the left, Kayla's on the right? Is that right?
Yeah, I'm Olivia.
Okay.
Yeah, Olivia was talking, but we didn't. Your microphone didn't pick you up.
Oh,
So.
I said if Bella's good at 1 to 2,
Okay, so let's try and do Tuesdays and Thursdays. Tuesday, Thursday this week, because that gives us kind of gives us a day in between, and then we'll meet again on Saturday. I know it's a lot, but I think we need to kind of get moving. So cool. With that, I think we can call
Sorry, my computer froze. 1 to 2 on Wednesday.
Tuesday.
Tuesday. Okay, cool. Sorry, my computer froze.
Tuesday, Thursday. So that way you have a day out, and then we meet, and we got a day, got a day, and then we have Saturday meeting, and then
Sounds good.
Okay, cool. I will see you guys later. I'll see you guys on Tuesday. I'll send out
Alright.
an invite. So,
Bye,
okay,
thank
bye.
Yeah. Thanks, everyone.
See ya.
All right. Bye. Oh, leaving.